In this video, I will be explaining how to draw Lewis structures and how to determine if the molecule is polar or nonpolar based on the Lewis structure. So we're going to start with CCl4. We know that this molecule is going to have 32 valence electrons because of the 4 valence electrons found in carbon plus the 7 valence electrons found in Cl times 4 because there's 4 Cl's in this molecule, and this is going to equal 32. We're going to start by putting carbon in the center and bonding the Cl's around the carbon. We know that this is the way to make the resonance, to make the Lewis structure, because carbon likes to make 4 bonds, and Cl likes to make 1 bond and have 3 non-bonding pairs. Because carbon is a central atom and it has 4 non-bonding pairs, bonding pairs, we are going to have a molecular geometry of tetrahedral. Now we're going to draw the partial charges. Because Cl has a higher electronegativity than carbon, it is going to have a partial negative charge. All of the Cl's will have this. Because carbon has a lower electronegativity than Cl, it is going to have a partial positive charge. We draw dipoles by going from the lower electronegativity to the higher. So they are going to look like this. Carbon to Cl, carbon to Cl, carbon to Cl, and carbon to Cl. All of these dipoles are going to be equal in length. This is because all of the domains are the same on the central atom, and the bond dipoles cancel, so there is no molecular dipole. Therefore, this molecule will be nonpolar. Next, we're going to look at SO3. SO3 has 24 valence electrons, and this is its Lewis structure. Because SO3 can expand, this is what it will look like. It will have 2 bonds on each of its domains. For 3 domains, and they're all bonding, this molecular geometry is trigonal planar. We know that oxygen has a higher electronegativity than sulfur, so it is going to have a partial negative charge, and sulfur will have a partial positive. Again, the dipoles will go from low to high. Since all of the domains are equal around the central atom, the bond dipoles will cancel and there will be no molecular net dipole, meaning this will be nonpolar. Next, we have OF2. OF2 has 20 valence electrons, and this is its Lewis structure. We know that its molecular geometry is bent because it has 2 bonding around the central atom and 2 non-bonding. Because fluorine has a higher electronegativity, it is going to have a partial negative charge, and oxygen will have the partial positive. The dipoles will go from oxygen to fluorine. These dipoles going to fluorine from oxygen are equal. However, because of the 2 non-bonding that we have around the oxygen, this is going to create a higher pull on the oxygen atom. So the domains are not all the same on the central atom, and the dipoles will not cancel. So there will be a net dipole, making the molecule polar. Next, we have BeCl2. This is its resonance its Lewis structure, This will have 16 valence electrons, and the molecular geometry will be linear because it has 2 domains and they're both bonding. Cl will have the partial negative charge because it has a higher electronegativity than beryllium, and beryllium will have a partial positive charge. The dipoles will go from beryllium to chlorine, and because all the domains are the same around beryllium, the central atom, the dipoles will cancel, and there will be no net molecular dipole. So this will be nonpolar. Next, we're going to look at ozone, or O3. We know that ozone has 18 valence electrons. However, in order to obtain a good Lewis structure, we must have the lowest formal charges on each of the oxygens. We do this because this second bond between this O and this O will actually represent 1/2 of a bond. This bond will go from this to this, so it will be a shared bond. So each O will have a 1.5 bond to the central O atom. Again, because the domains are not all the same around the central atom, the dipoles will not cancel. So there will be a net dipole and the molecule will be polar. Some common mistakes that students can make when doing these type of problems are the Lewis structure. One mistake you can make is counting the wrong amount of valence electrons and not understanding where to put the valence electrons around the atoms. Another mistake you can make is if you need to draw a resonance structure. Make sure you understand that for Lewis structures, you want to have the lowest amount of formal charges on each of the atom. So you will have to determine which structure will be best for the molecule. Another mistake that students can make is putting the wrong partial charge on an atom. Remember that if electronegativity is higher, it will have a partial negative charge. And if electronegativity is lower, it will have a partial positive charge.